So, we've never tried this before, but luckily there are enough now. Share with somebody for a second. I'll bring you this in just a second. So, at your corners, I want you guys to clip these together where the dimpled out section fits into the dimpled in section. And there's a technical way that there's a top and bottom. If you match like every top with, no, that may not work correctly. Top with bottom, top with bottom. Yeah, you want to connect these three legs and make a triangle. So you want to make this. Now, when I condense all of these down to the shortest that they can be, I should see right here, everyone find a little box where you can see the length. There's a little box on each of these that has a tiny little arrow that tells you how long it is. Now, what you guys should all see right now is lengths of 30, 30, and 30. No, you do not need the magnet things. We're not using those yet. So you're just clipping together the corner dimples.
Wow. Okay.
Is anyone having an issue getting them connected? Like clipping the corners, not the magnets, the actual clips on the corners. Yeah, help each other out, guys. Or is anyone having issues finding that 30 in the little box? So now, hold up. Keep your bottom leg the length that it is. Grab the top and pull up. Now, I don't care how you pull up, but then what you should notice in the boxes, hey guys, I need your attention. What you should notice in the boxes is your numbers have changed. So now, my numbers up here, I've got a 40, 44, 50, and 30. So here's what I'm going to need you guys doing. On your notes page, or on a separate sheet of paper, because I'm getting around with notes. I don't know exactly where I stopped with notes. On your notes page or on a separate sheet of paper, I need you to make a table like this, where we're going to notate the short leg, the middle leg. Hey guys. I don't know why I'm continuously, like, every time I stop talking, there are other people talking. I don't know why. If you know what we're going to do, feel free to take over. I need you to notate at least 5 examples. Short leg, middle leg, and long leg. The 30, 30, 30 does not count. And neither does my new one that I just made, where I have 30, 44, and 50.
What are the boxes?
The boxes tell you how long. Oh, short, middle, long, just for the leg length. Oh, you need at least 5. So you need your own 5. I think I ordered 20. I think that's the issue, is we're just over 20. I also don't know why I have an odd one unless they just sent me an extra one. So
Extra.
I don't have extra legs. These are called angle legs. They're angled legs. Alright, who else needs notes? Who needs today's notes? You know this, right? Yeah. Andrew, you have today's notes. You guys have today's notes. You guys have today's notes. You can compare with your neighbors. Either on a separate sheet of paper or make a space on your sheet. I don't know how small you guys write. Some of you guys write small enough that you can fit it. So that it's in the video, I'm going to put my split this. Depends on what kind of triangle it is. is, but it could. If you make it isosceles, if it's got two legs that are the same. So we've got short, medium, and long legs. I need some of your guys' examples. Justin, give me one of yours.
50. Wait.
You gotta give me all three.
Yeah, 50, 50, and 50.
50, 50, and 50. Okay, somebody else. Xavier? You say 31, 40, and 50? Who else? Yeah.
Yeah, 50, 30, 32.
30, 32, and 50?
Yeah.
What about a really obtuse triangle? Like, what if I take my triangle and try to make one of the angles as big as possible? So if you try to make your angle as big as possible, I gotta make these shorter. That, again, gets my 30, 30, 50, but is there any other crap? What happens if I change? So, I could keep my 30, I could keep my 50, and I could keep changing green, right, up until a certain point. So really, my 30 and my 50, I could have 35, 40, 45, 8, 32, 30, and 50. Yep, right here. Give me some more just awkward ones, Andrew.
50, 50, 30.
So 30, 50, and 50. Abby?
30, 46, and 50.
Now, if you want to be able to manipulate your triangle even further. Now this gets a little tricky, so give me your eyeballs first. Notice, if I look at the back, these each have a magnet. And again, I've never done this before. You want to disconnect this. Try not to break it when you disconnect it.
Maybe they sent you an extra one just in case you break it.
Probably. They literally snap. We might stop there today. I don't know how much we need because we're only going so deep into these rules. Go ahead and leave your triangle connected as a triangle. Go ahead and just leave this for now. Hang on to it for now. We might play with these more later in the lesson. What if? Hold on. I don't need you guys to do this, but what if I disconnect this and I decide to say, all right, forget where the blue actually is. I'm going to go ahead and connect it. I should not have said the magnets on this red dot. So if I connect it on top of that slider, now instead of using the length in the box,
It's obtuse.
now I'm using the length written on the stick. So now I can get some other triangle leg lengths completely different than what I had previously. So, you guys can play with it this way, or Abby, because I already set yours. Here you go, you kind of...
Yay!
Now, give me your leg lengths now, Abby.
Okay. The blue one is 7.
7 for the short. What's the middle length? Those will still be in the boxes.
The middle length, there's both of them are 25.
Ooh, okay, so 7, 25, 25?
Yeah.
Anyone else take their triangle apart, rebuild it, and have any other lengths for me? Brandon, you rebuilt the triangle. You got any
Oh,
lengths you
wait.
need?
So we're supposed to use this thing in the box. I'm so
So 30, 35, 42. I think you're actually misreading that. 22. CJ. So you said 22, 30, 35. I have a question. Do we see a relationship? If instead of calling these small, medium, long, what if I call these leg A, leg B, and leg C? We're going to say legs A and B are my short legs. And my long leg, longest, will be C. A and B are my shorter. It doesn't matter which is which, just A and B are my short ones. Do we see a relationship? Okay, C is always bigger than A or B. If it's the longest, it's always bigger than them. But is C ever bigger than the sum of those two? Because if I take this triangle, if I try to make these the same, my long leg the same as my short legs, what happens as my short legs get shorter and shorter and shorter, and this compresses down and down and down, and all of a sudden, instead of, and I can put this on top to show this, I can get shorter and shorter
Until it becomes
and
a
shorter. Wait, what is it? What?
A line.
It will become a line.
I like what
So when this comes all the way down, we end up with a straight line. So one of the rules that we see here is our triangle inequality rule. So our triangle inequality rule tells us the possible lengths of our triangle legs. And these actually, we're not all the way quite there yet, but cross out this. We're going to write a little rule here.
I'm not sure.
So, go ahead and put your triangles down. I need people to quit playing.
Okay.
We need pencils now. We've got a triangle ABC. Go ahead and draw that C is your long leg. Our two rules that we just derived from that. When I add A and B, I'm going to drag the table up onto the TV so we can see it again. Look at all those table values. When I add A and B, 31 and 40, bigger than 50. 30 and 32, bigger than 50. 30 and 50, bigger than 50. 7 and 25, bigger than 25. So these are always bigger than the third leg. Now likewise, that statement can be turned around and C has to be smaller than the sum. Is there any other rule we can make here? So B and C are always bigger than A. So that's kind of obvious because they're the longer legs. Yeah, the angle between them. So we're going to revisit this, but this is one of the most important triangle rules. The sum of your short sides must be longer, greater than, not equal to the third. That's where people get screwed up. They think that they can be equal. So let's look at drawing some triangles. If you are told to draw triangles, you put it down, like down, on the floor, put it down. If you can't resist it, put it on the floor. When we go to draw triangles, a lot of times we're given some information. So let's say we've been given some info to make a new piece for the school set for our drama club, and the pieces of wood that we have to work with are 4 feet, 5 feet, 4 feet, 7 feet, and 6 feet. Three people from the set make those 3 triangles.
Talk to the office, please.
So, my question, are these triangles So if we label these sides, AC is my 4 unit. FD is my 4 unit. And GI is my 4 unit. Go ahead and label these. BC is my 6. EF is my 6. And IH is my 6. My remaining side is my 7. All my lengths are rigid. They all have to connect at the corners. Are these triangles different, or do they just look different? So these triangles are identical. They're just manipulated. Just turned, or you can say manipulated. Because you can flip them. They only look different. Justin?
Can we decide the short lengths just by their what the distances?
What do you mean?
Like 4 and 6, would those be the short?
Yeah, so short, medium, and long. So we're just comparing lengths. Yeah. So if we look here, 4 and 6 have to be bigger than 7, or 7 has to be smaller than those two. Because if they were equal, it'd flatten out into a straight line. So what about in the got it? So you're trying a new prop, and you're using wood pieces of 5 feet, 10 feet, and 11 feet, and your friend sketches this plan. Would anyone using those 3 pieces be able to build anything different? Now, think for a moment. Don't write this down. But what if I had 5, 10, 11, and 7, and we were making a polygon? You don't have to write this. So I could do 5, 10, 11, 7, or that would actually probably have to be 5, 7, 10, 11. Or I could go 7, 11, 10, 5. Like, I can make this in different ways because as soon as I go beyond 3 sides, I can piece them together differently. So what we're really looking at here is when we have 3 sides. And if you guys played with Legos or erector sets or things like that, you're probably fairly used to this. Can I piece them together differently? In vertex A, B, and C, can they change actually where they are? That makes it a different shape. Abby?
Isn't it yes? Can't you?
So think about if I have 3 legs. 3
Oh,
legs to my
wait.
triangle.
You can't make it.
Black, red, and green, right?
Well, if you have.
Red touches black, red touches green, and green touches black. I re-scramble these.
Well, it depends.
Red touches black, red touches green, and green touches black. If I re-scramble these, red touches green, green touches black, and black touches red.
So the triangle or the
Well, it depends of the
What do you
number.
say?
We're talking about the triangle, the 4 pieces.
So the 4 pieces, we know we can rearrange them differently, right? Because I've got more
We
pieces. to work
actually
with.
no.
I can
You
put them in
can't
different order.
change them to a different.
3 pieces, I always end up with the same
Because it's an
intersections.
odd
Even if I change what order it is, I end up with the same shape, just manipulated or turned. It's always the same thing. It just looks different. So these are all, again, going to only give you one option. And our reason that we only have one option is because we have 3 lengths. I just totally skipped the letter. Or we have all 3 legs. So now, I'm going to push you a step further. We already answered the got it. If we have all 3 lengths, we get one triangle. It can look different, but it will be the same. So we already answered that, got it. Sorry, I'm gonna push you once we get to the back. I forgot what was next. A little bit of verbiage here, vocabulary. If it is an included side, that means it's between angles that we know. So right between or right by two angles, right between them, I mean, two known angles. So obviously we have to know what they are. Two known angles. An included angle, well, you guys can probably guess, is the angle included between two sides. So we got examples of both here. A is included if I know AB and AC. BC is included as a side if I know these two angles. Questions on that? If it's included, it's got to be between two things we know.
So, if they're not known, if the two angles aren't known, would they not be included?
No, for it to be included, we must know what the size of those angles are. So, if we have side lengths 3 and 4 and an included 90-degree angle, this is where it helps us to know that verbiage. Like knowing how to identify which word tells you what. Like the verb, like the action that tells you do or place or whatever. So I've got a 3 side, a 4 side, and an included 90-degree angle, which tells me there's 90 degrees between my 3 and 4 side. So let's draw what they've given us. When we talked in 12.1 about drawing shapes, what's the easiest way to start drawing a shape? What are you saying? Okay, what would we draw first? An angle or a side or what? Anthony? Which side? Yeah, the easiest way to do it is do your longest side first. So go ahead and draw 4 inches. If you've got a ruler, convenient, or you can just label it. You can say, okay, this is 4 inches. Then we would need to measure a right angle right here. And we would need to measure this to be 3 inches. Now, have we done what they told us? Do we have a 3-inch side and a 4-inch side? Yeah. Do I have a right angle? Is it included between my sides? I did everything they told me. Can I make a triangle? If I draw a line, right? Like they didn't say you can't draw a third line. They just didn't tell me what to do. So if I draw a third line here, do we have a triangle? Yeah. Did I do what they asked me to do? And this actually would come out to be 5 inches. This is the most famous right triangle, and this is called, I would like you to write this down, please, a Pythagorean triple. Does triple have 2 P's or 1?
1.
Sure it doesn't have 3?
Oh, I get it.
So, a Pythagorean triple is this perfect 3, 4, 5, which actually if we put it in our table will all hold true. 3 and 4 are bigger than 5. 5 and 3 are bigger than 4. 4 and 5 are bigger than 3. It works out. But I can keep going. I can make other triangles. If I double these lengths, I could do 6, 8, and 10, and that's a perfect Pythagorean triple. If I triple their lengths, I could do 9, 12, and 15, and that's a Pythagorean triple. If I quadruple their lengths, I could do 12, 16, and 20. That's a Pythagorean triple. I can keep going, making perfect Pythagorean triple right triangles. We don't have to, but we can. These are all possible perfect lengths of a right triangle. Abby?
I don't get it. Do they either have to be like 1 away or some number away?
So we'll get to the Pythagorean theorem. It's more of an 8th grade standard. But what Pythagorean deals with is only right triangles and only of a specific type. Well, actually, all right triangles do this, but the relationship that they have is that that short side squared plus the other short side squared equals the long side squared. So if I did 3 squared plus 4 squared, that would equal 5 squared. If I did 6 squared plus 8 squared, that would equal 10 squared. 9 squared plus 12 squared would equal 15 squared. That's why these are Pythagorean triples. They work in this formula.
Oh.
Because this is the Pythagorean
Formula?
right there. Technically called a theorem. A theorem is a generally agreed upon mathematical idea or principle or relationship. So we've tested it enough to say this works. We can now say it's the
So many
Pythagorean theorem.
confusing words that go into math.
Mm-hmm. But we couldn't just say it's like the Pythagorean idea or the Pythagorean
That
like
makes no
solution,
sense.
like because it's better than that. A theorem, like if you look up what a theorem is, it's like an agreed upon,
Science-y.
tested. We've checked it. We know it works.
It has to have its own word. It's so special.
So, see, do we have enough info here? You might want to grab a protractor or something. I've got 2 sides and an angle. Now I've got labels. Notice I've got R and R and R. So my R's tell me that that's going to be included. Can I use yours as an example, Justin? At the end of class, where's your third side? Can I have your third side? At the end of class, when I ask you guys to turn these in, try to make certain, like, if you would, leave them connected if possible, and just try to kind of flatten them. So you're going to break one of your vertexes, and you're just kind of going to rotate this to sort of like flatten out. Try to keep your 3 legs together if possible. If it doesn't flatten, it's okay. You piece them together in the wrong order. It's fine. Just if it works, you can leave them flat and make life easy. You'd have to clip them differently. So you have to have like top to bottom and bottom to top and that sort of thing. But it all depends on what order you put them in. So it's fine. If they don't, just pop them all off. It's okay. So, we would start with your long side. I'm going to label this R, Q, sorry. So go ahead and put those back down, please, guys, and do with me. And this was 12 centimeters. Angle R has to be 40, so I'm pretty good at approximating that.
Can we just approximate it?
And then if this is 8 centimeters, now the question it asks is interesting. Is this triangle unique? Now, it doesn't mean, is it special? Is it going to have a good future? It means, is there only one of it? When I do those commands, angle R is 40, RQ is 12, and RS is 8. Well, I haven't even made my triangle yet. I need to finish connecting it. So when I finish connecting it, though, now I've got my triangle. Would there be any other way to meet these criteria and make a different, not just different looking, but a physically different triangle? See some head shaking now.
No.
We can, real quickly,
Oh wait,
just
yeah.
because we're running out of time. Here's your rules for unique or more than one triangle. The only time that we're going to get possibly more than one triangle, and we'll come back to this to highlight it, is when 2 side lengths and a non-included non-included angle measure. This angle that they gave us, it's between two sides that we know it's included. So when it gives me two pieces of info for side lengths and an included angle, this makes a unique triangle. Because this was included. Because the angle is included. Makes one unique triangle. And right here for your got it, we just answered that essentially. We always make it unique. If we're given the two sides, and the most important thing here is that the angle's included. If the angle's not included, you can get more than one triangle. Any questions? Try the example down here for triangle ABC. You can choose whatever units you want. So if you've got a ruler, I'd probably go centimeters might be easiest. So if I start drawing this, I chose my long side to draw first. I drew CA. And if I've drawn C and I've drawn A, I know that B is going to be out here somewhere. Right? B's floating around out here. Now the only other thing I know about B is it's connected from A via 6 units. And it's connected to C via this angle. Because we know that since C's in the middle, it's at vertex C. So if I go to make my angle C 44 degrees, I'd lay my protractor on here, line up your crosshairs, that whole process, find your 0, and we get 44 degrees. But do I know how long this side is going to be? Well, this is going to be CB, right? This is headed to B somewhere out here. Do I know how long CB needs to be? I've been given CA and AB, but no CB. Okay, we know it's got to at least be over 2. So I like you're saying at least 3, but it's actually over 2. So what Anthony identified was, okay, look at the difference between these. This at least has to be greater than 2, because if this is going to be 6, so when we connect that together, that's 6 units. To be not a flat line, this would need to be bigger than 2. So it could be 3. Anthony went to the next integer. Could be 4. Could be 5. We actually will get a limit at some point. We're going to look at that limiting factor. But do we know what length it is? No. So since we don't know what length this is, and all that we know is it has to be more than 2, do we get one unique triangle, or could we make multiple triangles?
Wait, well, AB
We
has
could
to be
make
6.
multiple triangles here. So multiple triangles are possible. Multiple possible formations. Because this is non-included.
So the reason why it's not included because there is not an exact unit for one of the sides.
We don't. The side that connects the angle
It doesn't
is
have.
unknown. That's the issue. We know something about it. It's gotta be bigger than 2, but we don't know anything else. That's the issue. So our got it question here. If you form a triangle given 2 side lengths and a non-included angle, how many possibilities are there? 1 or multiple?
Wouldn't it be multiple?
Circle,
It's
highlight,
not
star, something for
included.
the not included. This gives you multiple possibilities. And the last thing, especially to help you with your homework, if you're trying to identify how many triangles can be made, and there's not a bunch of these questions, I don't drill it too hard. Here's your options. A unique triangle, if I know all 3 side lengths, I only have 3 sides, and I have to choose one, then the other, there's only one triangle that can be made. I can flip it, rotate it, whatever, but it's still one triangle. And I would highlight this or underline it, the included angle versus the non-included angle. Non-included will give you more than one option. Included gives you less. So since we have a couple minutes left, I want to think about something. We just talked about that triangle with legs of 6 and 8. And we said it had to be more than 2. I want us to think about this a little bit more. So somewhere, jot out your triangle. We've got 8. And we've got a 6. If I try to make it small, like let's pursue, what if I make this 6 a really small angle? Then my third side here could be just over 2, and we could say it's like 2.1. Really, all you need to know is that it's more than 2. It cannot be 2, because 2 would make it a
So
straight
it
line.
could be multiple formations because.
But then, what if my 6 went out? I'm going to go below the triangle now. Okay, I'm going to change colors so as not to confuse you. What if my 6 went this way? Then what does the third side
It's gotta be
needing to
way more than 6. And
So
like
it's gotta be
12.
more than 2, more than 3, more than 4, more than 5.
Probably gonna be like 12.
What would my green line be if this laid down flat?
180 degrees.
What's 6 plus 8?
14.
14. This green line will have to be less than 14. So if you want a real rule for the third side, I would write this down somewhere. My third side length it's going to be greater, so let's say S for side length, because it doesn't matter if it's your A, your B, or your C. It doesn't matter if it's the small, the medium, or the long. It's going to be bigger than their difference, right? It was bigger than 2 here. So we did B minus A, which in this case was 8 minus 6, which was 2. So we got 2 is, sorry, this is backwards. Please flip that. S is greater than, so B minus A is smaller than. We're going to actually write a double inequality here. But this side has to be smaller than the sum. So it has to be bigger than the difference smaller than the sum. So this is our real rule, which in this situation gave us 2 was less than, the side length was less than 14. So my side length will be somewhere between 2 and 14. Can't be 2, and it can't be 14.
It's gotta be in between.
Yeah, so it could be 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 13.5, 13.8, 13.9. Cannot be 14.
13.0.
That's all the time we have for today. We will pick this up tomorrow. Please get all your end legs or protractors or whatever. Please disconnect them. So don't do what Hayden just did where you drop in to either stack them flat, or if they don't stack flat, just disconnect them. So I'm not trying to pick on you. You just did it first and it was funny.